So on this problem, we have a mechanism that kind of spans a corner of a roof or something, and there are oh no, actually there's 6 linkages in it. 4 of them are two force members, so we can basically just write their forces down because we know what direction they act in. And so we have a whole lot of points to define in this structure. And so I used A as the origin, and then we have B, C, D, E, F, G, H, and then I also defined a new point I that's not in the book, but this is where the load, the external load acts. And all of these dimensions are given in terms of A. So again, in this problem, the scale doesn't matter. A could be a millimeter, it could be a kilometer. So yeah, we'll get the same result. And then also, we are not given P, so again, that can be a whatever type of force load we have. So what we have now is these four two force members. One is at A, so one connects point A to ground, and it has a direction, has a magnitude F, and is in the direction AF, okay, which actually is in the negative Y direction. And then B is has a magnitude B and is in direction BG, which is actually a negative 45 degree angle. C is where the two non-two force members are pinned together, so that has generally 2 unknown components. D is a two force member that connects point D to point G, so it has a direction G, and it is a let's see, this would be a 135 degree angle. And then E, force E connects point E to H, is in the two force member that connects E to H, so it has a magnitude E and a direction EH, which happens to be in the negative X direction. And then the external load has a magnitude P in the negative Y direction. So I have a ton of information here. We have 1, 2, 3, 4, 5, 6 unknowns. So we need to find two sets of force moment balances. So I took A, B, C, and I. So this is the top member, and so some of the forces and moments on the top member, it isolated from the rest of the body. And then I sum the forces on the vertical member. So this was the horizontal member, the vertical member. And again, because C is internal force, we need to make sure that one of these has a negative sign in it, so that whenever we have FC here in our summation, or RC cross FC in our summation, we have a minus sign up front here. So we basically, this gives us 3 equations, this gives us 3 equations, so we get 6 equations, and we have 6 unknowns, and we can go back and do the algebra to solve those. And we get that FA is minus P over 2, FB is P over square root of 2, FD is square root of 2 times P, and FE is minus 2P. So we can kind of look at our free body diagrams of these two members, and then these would be the two force members down here. So FA, the positive we said was down, right, because it was from A to F, so that's positive. So it's actually acting up, which means this is acting down and this is acting up, which means this member is in compression. And then that makes some sense, I think. Again, these mechanisms are really hard to make sense of just out of your intuition. So let's see here. B went from B to G, right? So it is it is, let's see here, this was this way, so B to G, so it's positive this way, so then this is positive, and then this is positive on the, so this bar, this member BG is in tension. Okay, that makes a little bit of sense. And so FD was positive this way. And so we had, it is a positive value, so F, this member here is in tension, and I think that makes some sense. And then this member here is in compression again, because this force is actually acting this way, so this one is acting this way. Right, so, and then this one is acting this way. So we're, we're basically pushing out on this, and we're pushing out on this, which means that we're squeezing these two members here. So these two ones over here are in compression, and these two diagonal ones are in tension.